All right, Jenny, buckle up, because today we're diving into something that sounds a bit like sci-fi, but it's real, it's happening, and it's set to change how we think about, well, soap, and a whole lot more, it turns out.
Soap, Mark? Really? I was ready for quantum computing or interstellar travel, and you bring me to the laundry room? What's going on here?
No, hear me out. This isn't just about soap. This is about NobleAI, a company that just teamed up with none other than ExxonMobil. Yes, you heard that right, ExxonMobil. And they're presenting at the AOCS annual meeting about using AI to revolutionize cleaning product formulation. It's like Batman partnering with a quantum physicist to make a cleaner Gotham, but for real, and for suds.
Okay, that's a plot twist I didn't see coming. ExxonMobil, a fossil fuel titan, teaming up with an AI startup for eco-friendly detergents? It's certainly unexpected, but honestly, if it means better, more efficient cleaners, I'm all ears. Tell me more, you've piqued my curiosity.
Exactly. The core of it is NobleAI's science-based AI and their VIP platform. Historically, to figure out how cleaning products work, you'd mix a bunch of stuff in a lab, cross your fingers, and see what happens. It's really time-consuming, expensive, and creates a fair bit of chemical waste, believe it or not.
So basically, a lot of trial and error. And probably error. Until finally you get something that works. That makes sense for why it costs so much to develop new products. It sounds archaic, frankly, for such a modern industry.
Precisely. But here's the cool part. NobleAI's VIP platform can model complex mixtures of non-ionic surfactants. Those are the key cleaning agents, virtually. Instead of looking at individual ingredients, which is what most previous research did, they're modeling how the entire blend interacts at a molecular level. Think of it like conducting thousands of experiments in a computer in minutes, instead of months or even years in a physical lab. It's a quantum leap in efficiency.
Thousands of experiments in minutes? Mark, that's wild. So they're predicting how molecular structures will behave in a mixture without even mixing them? That's a huge leap. What does that mean for a company like ExxonMobil, which isn't exactly known for speed usually?
It means their R&D cycles for cleaning products could plummet from years to just days. A dramatic shift. Imagine shrinking a decade's work to what feels like a coffee break. NobleAI's CEO, Sunil Sanghavi, actually calls it a paradigm shift away from slow, expensive, lab-centric processes towards rapid, inexpensive, computer-aided ones. And in a press release, they've hinted at reducing development costs by over 70% and minimizing waste. That's a huge win for sustainability, not just speed.
70% cost reduction and less waste? That's good for the bottom line, and a significant step toward greener chemistry. This AI-driven shift could redefine how we balance speed and ethics in industrial R&D. But I have to ask the obvious question. Are we sacrificing those happy, serendipitous discoveries for efficiency here? You know, the accidental breakthroughs that happen in a traditional lab setting?
That's a great question, Jenny, and a valid tension point. But I think it might be the opposite. The AI handles the grunt work predictions, narrowing down the possibilities. This frees up scientists to explore truly novel what-ifs, those creative ideas that were previously buried under the busy work of endless physical trials. They can iterate 20 times faster than before, so they can test more crazy ideas effectively, which could spark even more unforeseen discoveries.
Okay, that makes sense. If the AI handles the mundane, the human ingenuity can truly soar. And you mentioned democratizing AI. They're touting tools like DYOM, deploy your own models, and MBFF, model builder formulation. It sounds utopian, but is this tech truly accessible, or just another premium tool for corporate elites and giants like ExxonMobil?
Another sharp question. While NobleAI's aim is to make this accessible, and these new tools simplify things for non-AI experts, true accessibility depends on a few things. Cost, obviously. And also, how easily smaller manufacturers can integrate this into their existing workflows. We need guardrails so mom-and-pop innovators aren't priced out of the green product revolution. We don't want to create a two-tiered system of innovation here.
Right. It's one thing to say minutes instead of years, it's another to empower everyone to actually use it. So beyond cleaning products, where else are we seeing NobleAI's science-based AI making waves? Because if it works for surfactants, I imagine it could have broader applications.
Absolutely. Their public disclosures show applications stretching far beyond detergents. We're talking asset performance optimization in the energy sector. Think oil wells, forecasting uncertainty through predictive analytics. Then there's broader chemicals and materials science, polymers, coatings, adhesives, even pharmaceuticals. Essentially, anything that relies on understanding how molecules interact can benefit. It's a fundamental shift in how chemistry is done computationally.
So it's not just about cleaner dishes for me, but more efficient energy extraction and maybe even new drug discoveries. This is truly fascinating, Mark. But I have to ask, what about quantifiable proof? Are there any hard numbers, like specific performance metrics or validation data, on how accurate these predictions are? Or how much faster they can truly make things compared to traditional methods? The press releases sound great, but where's the beef, you know?
You hit on a crucial point, Jenny. While the press releases and AOCS presentation descriptions tout significant acceleration and cost savings, they don't actually provide specific statistical performance metrics. We're not seeing percentages of predictive accuracy validated against experimental data, or hard benchmarks for computational speed. They claim months to minutes, but the detailed how much faster or how much more accurate in hard numbers isn't out there in the public materials we have. It leaves some room for skepticism, one could argue.
That's something to keep an eye on. It's certainly exciting, but without those numbers, it's difficult to fully grasp the true scale of the impact. Still, the promise is huge. So you're saying this isn't just a one-off presentation? NobleAI is rolling out these capabilities more broadly, right?
That's correct. The AOCS presentation was a high-profile demonstration with ExxonMobil, but NobleAI has been actively commercializing their VIP platform and related tools. This signals a broader push to make this technology widely available as a software-as-a-service solution. It's not just a research project, it's becoming an industry tool, much like other specialized software that businesses use daily.
Well, Mark, from humble soap to global energy, it sounds like NobleAI is making quite a splash, no pun intended. The idea of compressing R&D cycles and moving towards more sustainable chemistry, even with the current lack of specific hard data, is incredibly compelling. It certainly shifts the paradigm, and that's worth talking about.
It certainly does. And it's a brilliant example of how AI isn't just about chatbots or self-driving cars, it's revolutionizing industries at a fundamental, molecular level. This is the kind of innovation that's genuinely exciting, making real-world impact, reducing waste, and accelerating progress. It's not just smart, it's useful. And that, to me, is the coolest kind of tech.
Couldn't agree more. And on that incredibly useful note, that's all the time we have for today. Thank you, Mark, for another illuminating conversation.
Always a pleasure, Jenny. Thanks for joining me on this dive into the future of chemistry. See you all next time.